Algebra 2, the normal distribution teacher talk. So after you complete these problems and watch this video, if you still have any questions about any of these problems or anything else covered in this concept, please be sure to go check in with one of the teachers. Okay, so refer to your notes to help answer these questions. For the normal curve, give the percent of the area under the curve. So hopefully you found, well, first of all, let's talk about the normal curve and let's write in the percentages for each standard deviation mark. So as you can see, one standard deviation away from the mean, each section would contain about 34% of the respondents. And then 2 standard deviations would be 13.5, 3 would be 2 and 35% of the population, and 3 standard deviations or more away would be 1500ths. So if we look at the curve on number 1, the shaded area is everything to the left of the mean. And so that is simply 50% of the data. That would be the probability that a data value would fall within that area. Number 2, we're looking for the probability that would be 2 standard deviations above the mean. And so we can simply add up the percents. So that would be 34 plus 13.5, which would give us 47.5% chance that a score or a data value would fall within that range. Now we're going to find the probability, and again, we're going to think of those percentages for each mean area. So I'm going to label that here. And then number 3 is we want the probability that some value in the data set is greater than 3 standard deviations above the mean. And so that would be that very small amount, that 0.15%. That's way up on the right of our normal curve. Number 4, we want the probability that a score is greater than 3 standard deviations below the mean. So that is everything but that small percentage way on the left. So we can take 100 and subtract that 0.15, and so it would be a 99 and 0.85% chance. And then number 5, we want the probability that some data value is between the mean and 2 standard deviations below. So if we add up those percent chances, we will get 47.5% chance. Now, on a survey given to schools in the U.S., including LPS, the percents of school responding favorably to the question, how well students deliberately use strategies to manage their own learning, are normally distributed with the mean of 61 and a standard deviation of 11. So hopefully you labeled your curve to look something like this. So you would have 61 in the middle, you would have 3 marks above and 3 marks below for our standard deviation, and then we would add 11 and subtract 11 to get each of those standard deviation labels. So we want to find the probability for 6, 7, and 8 so that there is a percent that falls between 50 and 72. So let's label the percentage on a normal curve, and then we'll add up the percents between 50 and 72, which is just 1 standard deviation above and below the mean, which would be a 68% chance. Between 39 and 61 would be 34 and 13.5, or a 47.5% chance, and at least 72 would be 13.5, 2 and 3500ths plus 1500ths for a total of a 16% chance that a score would, or percent would end up at least 72 in that particular survey. Liberty students responded 72% favorably on questions that we were just talking about. What's the probability that an individual LPS student responded not favorably? So this is just asking, so there I'll mark our values on the normal curve, and you already have it on your paper. So favorably, LPS is 72, and then we're not going to look at the probability, we're going to look at the percent chance, or the percent that an individual would respond not favorably. So that's just 100 minus 72, 18%. Now looking at the normal curve, describe Liberty's responses compared to those nationally. So 16% of the national responses are higher than Liberty, so above 72, and 84% are lower. We're going to determine whether each histogram has a normal distribution. So hopefully on yours, you drew the curve over. So on A, and then if you look, notice how those scores are piled up on the upper end. So this is what we call skewed left. So majority of the values are in the upper end of the range. Now for B, when you draw that curve, hopefully you noticed that the majority of values were bunching up in the lower end. So we call this data set skewed right rather than a normal distribution. Okay, and that ends the teacher talk. Again, if you still have any question or confusion about any of these questions or other things on the notes, please go see one of the teachers.